Hi, Calc class. This is Mr. Ebersold's mom. You can call me Gigi. And I'm going to give you a little introduction to slope fields. Right now, the videographer is Mr. Ebersold's stepdad. You can call him Grandpa Joe. And he's also a mathematician. He was on the faculty at the University of Cincinnati, and he's retired. So if you hear anybody giggling at what I say, you know it's him. So anyway, let's see if I can start and tell you a little bit about slope fields. The first thing I want to do is let you know that this is similar to things that you've done before. So let's take a look at this graph where we've done this, you did this months ago, where you said, okay, I've got a derivative, and let's say it's y prime is x, and you would say, okay, in this area, since the derivative is positive, y is increasing, and in this area, you would say y is decreasing. And from that, you actually got an idea of what the graph looked like. You could say, okay, if it's decreasing, it goes down, and increasing, it goes up. And you would even say, since the derivative is always an increasing function itself, we're concave upward, and you get several different possible solutions to this. You can only get a particular solution if you had what we now are calling an initial value. So, for example, if you know that when x is 0, y is 2, here is your precise antiderivative. Now we're going into something a little different. So the question is, why in the world do we need something called a slope field? And that's because there's a few reasons. One is, let's put y. One is because the derivative might not be given explicitly in terms of x. So an example of that we've seen in differential equations, maybe y prime is equal to x times y. Or maybe y prime is just in terms of y itself. So that would be one reason. And another reason is because you might have incoming data. And so instead of having y as a function, you just have data points for y prime. So you might say you're reading a meter of some sort. Think about when something goes off into space and it comes back with, and they come back with just readings instead of a function. And in a lot of real world situations, even like right now with our coronavirus, we might say, okay, here are the number of deaths today and tomorrow and the next day and the next day. And maybe that looks like an exponential curve, but it's not precisely an exponential curve. We only approximate our model with an exponential curve and see if the data fit it or not. So anyway, those are some of the ideas of why we're going to study slope fields. So can we pause for a second? I don't know.